Well, like John, this is a very great pleasure for me. It's also a great pleasure actually to share this with John, because when I opened the letter from the Tyler Prize Committee, before I first learned who the other person was, I was at my desk. I needed to avert my eyes only a little bit, and there's the great textbook of John Seinfeld, who is this kind of the Bible in this field on air pollution. Sort of like reading Shakespeare or Charles Dickens. You don't quite get it every time you read it, but you learn something more when you read it again. And of course, a long list of distinguished laureates in the past. I might note that afterwards you get to guess or vote on which one of us you think lived in Hawaii for 20 years. So I'm going to talk, John, we didn't coordinate, but we could have, because he talked from the top down. I'm going to talk from the bottom up. But I am going to get to the top eventually, toward the end of my talk. So we've been doing this for about a third of a million years, cooking with wood or other solid fuels. Indeed, you can call it the oldest human occupation, because Levi-Strauss, for example, perhaps the foremost anthropologist, certainly of the 20th century, used the control of fire as the defining moment when we changed from pre-human to human state. And that occurred a third of a million years ago, something we've been doing a long time. Today, we use not only wood, but here's wood, but crop residues. So 10,000 years ago, presumably when we first started growing things in agriculture, we probably started burning crop residues, and then maybe 1,000 years ago in certain parts of the world, coal started to being used. And they're still used by hundreds of millions, billions of people today. And they are the problem. Now I'm going to focus, coal has special problems, so I'm going to be focusing mostly on the biomass part of this. This is a picture in a Chinese village. Chinese households are very complicated in terms of energy, partly because of this mixture of fuels. Today, if we take a look at today, the use of these fuels is in sub-Saharan Africa, South Asia, and bits and pieces other places, China. Now the poor use these fuels. In fact, you could have no better definition of poor. Somebody sends you an email today from Mars and says, I'm going to be visiting tomorrow afternoon. I've only got 2 hours. How do I find poor people? Go to some place where they're cooking with open biomass fires. I can guarantee you that none of the billion poorest people in the world are using gas, and I can guarantee you that none of you is using open biomass fires in your households, or indeed any of the richest 3 billion people in the world. It is a characteristic of poverty, which complicates, of course, the epidemiology and other, how to separate the effects of the smoke from the effects of the poverty. Getting better or worse? Well, we all started, 100% of us, our ancestors, using these fuels, but what's the situation today? Well, this is roughly the way it looks. Here's the world population since 1950, and here is the population using solid fuels. So you can see back in 1950, it was, 60, 70% of the world was still using solid fuels. Now our current estimates are about 40%. So it's getting better, right? Went from 70% to 40%. We can go home. No, it's getting worse. This is absolute impacts. The absolute impact is going up. There are more people using these fuels today than there ever been in human history. There are more people using these fuels today than there were people in about 1940. It's not going away by itself, and this is a problem with poverty metrics in general. Why should the poor, these people down here, care that they're now 2 people where there used to be 1 person on the other side of the line? It's the absolute impacts that count. So it's a problem that's lasted 1/3 of a million years and is showing no signs of going away quickly by itself. Now, some people say, well, wood smoke is natural. I like the smell of it. It reminds me of campfires, Boy Scouts or whatever. Somebody who knows a little more will say, well, isn't wood just carbon, hydrogen, and oxygen? This is about all the chemistry you're going to get from me. Listening to John reminds me why I switched from chemistry to physics. And doesn't it burn to just CO2 and water? Well, if it burns completely, it burns to CO2 and water. The problem is it doesn't burn completely. And the combustion efficiency, that is the percent of the carbon that's converted to CO2, is far less than 100%, depending on the fuel and the stove. As much as 20% of it's converted to toxic substances. Now, is this guy exaggerating? A toxic substance is just wood smoke. Well, let me show you what's in that wood smoke. I lied. I guess I'm going to show you some chemistry. Here's some of the things that are found. Here, this is classic air pollutants like small particles, aerosols, but it's a vast range of noxious stuff. I put them in chemical categories, and then out at the end here in italics are known toxic substances. Maybe some of your favorite things: benzopyrene, benzene, formaldehyde, dioxin. All of these things found in wood smoke. Now, here's a test. What does this mixture of things remind you of? Well, I give my students a hint, that if you're in the health field and somebody asks a question you don't know the answer to, just say tobacco. And you're probably right. It's a good guess. This is the same as, what is tobacco? It's incomplete combustion of biomass. Now, the tobacco companies put some extra junk in it, and there are differences. But in the broad sense, it's the same set of things. They've identified 7,000 things in tobacco smoke, but they've had tens of billions of dollars of research. Got 4,000 things in wood smoke. I'm sure we'll catch up eventually, or probably not. They're always going to be ahead of us. A lot of stuff. Now, there's no nicotine in wood smoke. I would postulate the world would be a different place if there was nicotine in wood smoke. First of all, the good news is there'd be no tobacco companies, right? Bad news, there'd be no forests because people would have smoked them. But keep tobacco in mind. Most people have accepted the fact that sticking burning stuff in your mouth is bad for you. Now, many of us can remember decades previous when that wasn't the case, but most people have accepted that now. All right. Now think of 1,000 cigarettes an hour burning in your kitchen. That's what we're talking about here. Not in your mouth, but in your kitchen. And then maybe it's not so surprising that there's such big health effects when you think about it that way. And then secondly, babies don't smoke. Well, I did see one on YouTube that was smoking, but babies don't smoke, but babies are in kitchens. So this describes in a nutshell why we see such big health effects. All right, what comes out? And, I told the general category, but how much? Well, you can't measure everything all the time. Even the tobacco people don't do that. So I put down just a few of the big chemicals. And I just show you carbon monoxide particles, benzene, and so on. You don't need to know these numbers, but notice that the amount of the health-based standard is far underneath what we find in village houses. They're being exposed to a lot of this. In one sense, I just came from a WHO meeting to set guidelines, indoor air quality guidelines related to this. And I said, in one sense, we shouldn't need to go further than this. These three things are group 1 carcinogens, confirmed human carcinogens by the international agency that does such things. Why should we have to go further? Why should babies anywhere in the world be exposed to excess amounts of 3 known carcinogens, even aside all the other stuff? But unfortunately, the irony of this business is the evidence you need in these settings are much higher criteria for that evidence than we'd need. You wouldn't allow this in the U.S. The National Guard would come out if this was going on. The best single indicator is small particles, which is John, is the world's expert on aerosols. So I will speak about that mainly. It's certainly not the only thing in there, but it's just the best. It's just what cigarette people do. The tar on the back of the cigarettes, the amount of tar content, that's cigarettes people way of saying small particles. All right, so now they asked us to talk a little bit of our own, as John did, our own personal history on this. So I'm going to take this sort of timeline here and sort of describe what we've been doing, what I've been doing in this area. So the very first measurements of this, as far as we know, were in 1981, when the world was, 50% or so use of these fuels. This was in India, which at that time had 85% households using these fuels. Now, how did this happen? Well, I did some work in rural areas on an energy project, and right after I moved to Hawaii after my doctoral degree, and it didn't take very long in village houses to see these kinds of smoky situations. But I couldn't find anything. We didn't have, any way to search the internet or anything in those days, but we did the best we could. Couldn't find any studies. So, and the question is, how smoky is it? Large population with daily exposures, no measurements done apparently, but we can estimate little, simple little physics models. None of this chemistry stuff. We can estimate roughly what the indoor levels are. We know what fuel usage roughly. We know emission factors of these kinds of fuels. We know the household volume. Didn't know ventilation very well, but we could still estimate. So we did a study. It was published in 1983, but the work was done in 81. Basically, before it, we made a little model, estimated what these levels would be. Assumed a village house, volume, wood use, emission factors, and so on, based on fireplace studies in the EPA. And since we weren't sure about ventilation rates, we did a range of these, and these were the estimated levels of the particles in the room based on these different ventilation rates. And I know you don't know these units very well, but just consider that the health-based standard's around 100, and these were the numbers we were calculating. So we could hardly believe these numbers, yet we could find anything wrong with them. So what to do? Measure it. So we did the first study, which was in Gujarat in western India. And this, as far as we know, is the first person in human history to have her exposure measured in the oldest occupation in human history. And in Gujarat in 1881. Now, John showed you his instruments, airplanes filled with multi-million-dollar gadgets and teams of graduate students doing many flights over. Well, here's our instruments. And now, things have improved a bit since 1981, but not that much. So the pump is taking a sample of air through the filter here, right? Inner breathing zone. It's a pretty good example, illustration, example of what she's actually breathing. And, and then you take the filter and weigh it before and weigh it after, and you can do some chemical analysis and so on. So what did we find? Well, this is what we assumed, and this is what we found. 6,900 micrograms, apparent air exchange rate was about 13. Since then, we've done a lot of measurements of air exchange rates. It's right in the middle of the air exchange rates we typically find in these houses. And that's a lot of air exchange by American standards. Typical houses here, about 0.5 air changes per hour. But you couldn't possibly live in a house that had 0.5 air changes an hour and have 1,000 cigarettes an hour burning in your house. We also found other things that we've duplicated many times first. I mean, I had occasion to look at this old paper because of this. And, we found that cooking outdoors doesn't help all that much. The problem is not the indoor so much as the bad combustion. Lowers it, but it's still hardly anything healthy. We also found that the so-called improved stoves, what the Indian program used to call smokeless chullas, chullah is the word for cook stove, didn't do much. And you can see there's a slight reduction apparently in the amount averages for the smokeless chullas, but given the the uncertainties, standard deviation, they're not statistically significant. This is very typical. We found this dozens, not hundreds of times since. So-called improved stoves, so-called smokeless stoves generally don't work. And I'll talk more about that at the end. Here's an example of these so-called improved stoves. You might, just looking at them, you might doubt if they're working. Obviously, there might be a chimney there, but a lot of the smoke is not going up the chimney. We also found something else that directly relates to John and my overlap, so to speak. And that is, where does the pollution go? It goes out of the house. It doesn't disappear magically. It's around. And the levels in villages, outdoor levels, can be really substantial. Sorry, this is different units here. Multiply this by 1,000. So that's 1,000 micrograms. Remember, the standards are down here around 100. And look at this. I just took the device, started out in the fields during the cooking time, walked into the village. I didn't go into any house, just walked between the houses. And look at, we're getting hundreds of micrograms per cubic meter outside. So that's why we actually don't call it, I don't call it indoor air pollution problem anymore. Might start in the indoors, but it certainly doesn't stay there. So let me tell you a story of my life in a sense in this field. It was going to two conferences. I go to an air pollution conference, and I present some of these numbers, and they look at me sort of aghast. Good Lord, that we know there are health effects 20 times less than you're finding. You're dealing with the most vulnerable population, women and children in the poorest households. You don't need to do any more health work. Just go out and fix it. And so I get charged up and I go across the street to the International Health Meeting, and they say, look, I've got $10 per year per capita to spend in India on public health. Are you telling us to take money away from vaccines, antibiotics, maternal care? By the way, we don't even reach the whole population with those yet. And put it into, clean stoves? And I say, well, no, maybe I'm not saying that quite yet. We need to know the exact, we don't care what you found in Guatemala, we need to know it in India. We have to know the exact benefit you're going to get. Because we can't take $1 away from that $10 to do something unless we know we're going to get something from it. Or we go to the Gates Foundation. Now, the Gates Foundation, rich place, but $1 a year per capita in India, that's $1 billion. It uses up, the entire budget of the Gates Foundation. They want to know the same thing. So ironically, again, in the places with the most need, the most risk, have to have the best data. And then the next question they ask is, where are your randomized controlled trials? This is what the health community expects, to actually show what you can actually get with a real intervention. And you can understand. So, this is the title, published title of this, Following the Risk, Not the Money. And we did the first measurements in 81. We had a little meeting in 84 to see some colleagues, Peter Kunstetter, who's here somewhere, was one of the colleagues at this meeting, and to decide what to do with this. And we decided, well, the thing to show the world what was going on was a randomized control trial of pneumonia. Child pneumonia is the chief cause of death in world's children, and we think, well, now we know, but we thought then was probably caused by the smoke. All right, so how long do you think it took us to get funding? Well, we tried for several years in Nepal, couldn't get funding. WHO never has enough money to do big studies, but they had a committee that helped us find the best site. We visited 9 different sites around the world and chose Highland, Guatemala as the best site. More proposals and pilot work. Finally got funding in 2001. 17 years between deciding to do this and getting funding. No, we weren't obviously following the money. Main published results last year. So I don't even want to do that calculation. A lot of time between the deciding to do this and final publication, or not even final, we still got other things coming. There's the publication in Lancet last fall. All right, I'm not going to go through the whole thing. I mean, you might be interested in the site. Some of you may have traveled to Guatemala. It's in an area near the Mexican border, near Quetzaltenango is the big city, place called San Lorenzo. This is what we did. This is the typical situation. This is the most common cook stove arrangement in the world. 3 rocks, it's called, or 3 bricks sort of thing here. A mother cooking with a baby on her back. And this was the intervention we put in, randomly advanced chimney wood stove, very well liked by the population, and when maintained, very good at reducing the indoor air pollution. So we'll put that on our timeline. That was when we decided to do it, and that's when we got the funding. And that's when we got the publication. Oops. So we also wanted to measure exposure, because in one sense it doesn't matter what the concentration is, you really care about what people are breathing. So not so easy to measure exposure, a personal device like that pump, you can't put that on a baby, so we had to develop techniques for measuring exposures even on babies. This is not a baby, but you can see this device can even be worn by babies. So that took some time to develop and validate that. And we found, bottom line here, is that infants with a 90% reduction in the exposure had a 50% less pneumonia, which is the chief cause of death in the world's children. And now that's much better than you can get with any available vaccine, nutrition supplements, antibiotics, or whatever. So it's big result. Now, one study, not going to convince everybody right away, and there are 2 other ones now, one in Africa and one in Asia. And I'm an advisor, but not an investigator on those. But we learned something else. We learned that the chimneys caused the kitchen levels to go down by a factor of 10, but the average child exposure was only down by a factor of 2. Now, some kids had a greater increase in exposure, but the average was only a factor of 2. Why? Well, kids don't spend all day in the kitchen. They did, their exposure would go down by a factor of 10, but they don't. And the neighborhood pollution, or chimney, doesn't get rid of the smoke, it just moves it around. And so, for example, there was no significant difference between the two types of houses with the chimney stove or the non-chimney stove in the bedroom or the outdoor level. So the average kid benefited, but didn't get the full benefit. That factor of 10 was an unrealistic expectation in terms of the change in actual exposure. So as a result, my group, anyway, doesn't work on chimney stoves anymore, unless they're combined with good combustion. Get rid of that smoke in the first place. Don't have all that stuff being converted, that nasty stuff. Don't just plan on moving it around. You know, and here you can see, this house doesn't have a chimney, but you can see the smoke got to go somewhere, right? In fact, where does it go? Here's another view from our site in Guatemala, early in the morning. Quite common all over the world. And those 40% of households, there's going to be something like this going on. So where does it go? Well, it goes into John's databases. Here's another view of the global situation, 20-month average ground level PM 2.5. Somebody has converted these satellite measurements into some estimate of ground level. I don't want to go through it in detail, but look at these high levels in the big river valleys of India and China. What is that from? Those aren't cities. Sure, there might be some smoke coming from the cities, but there may be some brick kilns and maybe some agricultural burning and things, but a good portion of that is households. Densely populated by agricultural standards. Households burning stuff incompletely. Not surprising when you think about it. In fact, if you've ever driven through those areas in northern India or China, it looks like LA. Highly polluted. People think of rural areas as somehow magically clean. They're not, at least in this part of the world. How big are those? How big is it? Well, we don't, in fact, John and I are talking about a joint proposal, sort of triggered by our joint prize winning here, about actually pinning this down, adding his work on secondary aerosols. So I don't have secondary aerosols. This is primary aerosols based on NASA inventories. And about 50% of all particle air pollution, primary, in India from households, 30% in China. Not much bigger than transport. But there's another part of the particle picture, and that's the secondary, and we need to pin that down. But anyway, not a small actor, let's put it this way. A significant actor in outdoor air pollution in these countries, not just indoor or household. So now I don't have time to go through this, but we actually started doing some measurements related to climate impacts around 1990, and I'll show you somebody else's models for this. This is a group at Columbia University, the NASA Goddard laboratories there. And they made estimates of the total climate impact of different economic sectors. Now, this is complicated work to do. Models, assumptions, so on, presentational issues. But here's the vehicles. This is basically vehicles. And it shows, anything on the left is the cooling impact of that sector, from sulfate particles, for example, and things on the right are the warming, and this is ranked by the net impact, the highest being their estimate on road, second being household biomass use. And you can look for other sectors down here. Now, as I say, this is complex stuff, a lot of assumptions, even the metric, and then they chose a particular year. Different year you might get something different. So I'm not going to argue that it's second, but I'm just going to say it's up there with the big boys. You can't deal with climate change, effectively globally unless you deal with get household combustion. And I'm saying the same thing. You can't deal with outdoor air pollution, at least in those parts of the world, without dealing with household combustion. Indeed, what do you think is the chief cause of air pollution in the Bay Area, San Francisco Bay Area, where I come from? Wood smoke from fireplaces, and not much cooking with wood smoke, with wood. Chief cause in all of Canada. Chief cause in Denmark, Sweden, Finland, and Norway. Chief cause in Chile, Tasmania. So wood smoke from space heating or fireplaces is actually something that the developed countries shouldn't be very proud of, because we haven't dealt with it very well. But of course, it's not at the scale in terms of risk as when you're cooking with it. Now, I don't have time to go through the evidence based on the epidemiology and the health effects. I'll list some of the diseases later, but The next part of this story is in 2004, the World Health Organization did this so-called comparative risk assessment, and which is by far the most comprehensive thing of this type. And they compared all the, actually 26 major risk factors. I put a number of them here. And the metric here is DALYs. This is lost healthy life years. It's better than deaths. Everybody has to die. So you care about premature death, how premature, children count more than adults. They found malnutrition and measured as underweight as being the chief single cause of ill health in the world, followed by the HIV epidemic, and then high blood pressure, tobacco use, and so on. Here's the first environmental risk factor, unsafe water and sanitation, and here we were number 10. Now again, these aren't so accurate that you can really tell. I mean, that's probably different, but whether these are different or not. But up there with the big boys again, and this has certainly made a difference in terms of people paying attention to this. Now, if you like deaths instead, we can put in, this is about 2 million premature deaths. You should always say premature. You cannot prevent death. I'm sorry if that's news, but about 1 million. But notice this was urban, and the new assessment that's coming out this year will actually include rural, and it makes it much bigger because of all that rural outdoor air pollution. And now, let me ask you, part of my leaving the money and going to the risk was the first part of my career. My dissertation and early parts of my working career were related to nuclear power, nuclear risks, reactor safety, nuclear waste, and this kind of thing. And it's a natural place to go if you're a physicist. It's kind of technically sweet, I think as Fermi said. But if you train yourself to follow the risk, well, that's why I moved to household air pollution. But then the Fukushima accident last year caused me to think about this a bit more, so I thought I'd maybe put it in this burden of disease context. So I said, well, what if you had a very large nuclear power industry in the world, say 5,000, 7,000 reactors, something like that, and you had one Chernobyl accident per month? Now, that'd be, hard to imagine a worse situation than that. Chernobyl was far worse than Fukushima. 95% of the radioactive material was burned and sent into some of it into the stratosphere. No containment, no evacuation, no iodine pills. Terrible. Well, big studies have been done now on the health assessments, and these assessments can always change over time. And I'm not talking about what you might read on the web. I'm talking about authoritative assessments. So if you had 12 of these a year, how would it show up on this graph? Is it up there? Is it in here? Is it like malaria? I mean, what is it? Well, there's Chernobyl. So, confirms my switch back in the 80s. This risk is a lot bigger. And it confirms what, it's standard public health maximum. I mean, it's not the spectacular and rare that kills you, although it gets the news. It's the mundane, day in, day out, something that's been going on 300,000 years that is killing people. And, but that isn't necessarily where the money and the attention goes. Now, let me just say, this doesn't necessarily mean I'm pro-nuclear. I think the problems with nuclear power are different from radiation, but relate to proliferation, somebody stealing weapons material and making bombs, and that makes nuclear power, I think, a unreliable, expensive, and dangerous, unless efforts are made to internationalize the nuclear fuel cycle so that the plutonium and enriched uranium have no chance of being stolen, and it's very difficult to imagine how to do that. But it's more of a political than a technical issue. What about India? Well, generally, and maybe what people don't understand is that environmental risk factors are bigger in developing countries, both bigger in absolute and in relative terms, per capita. Unsafe indoor smoke was about 400,000 a year, if you like, and tobacco was about 700,000. Now you might ask, well, what's something wrong with the math here? I mean, the tobacco's further down, yet it's 700,000. Well, again, babies don't smoke. And there are babies dying here with a lot of lost life years, not there. So, first acceptance of global burden of disease, 2004. Now, the burden of disease is being redone, and I'm sorry I can't show you the results. They're going to be coming out in a couple of months. But we are adding, these are the diseases now that are included from household air pollution that are included. pneumonia and low birth weight in children, chronic obstructive pulmonary disease, lung cancer, heart disease, and cataracts in adults. There is pretty good evidence, actually, in tuberculosis, cervical cancer, and retarded physical and mental growth in children, but not considered sufficient to go above the line, so to speak, in the new burden. The next time the burden is done, I guarantee you these will be included. In fact, I can predict the set of diseases that will be included over time, exactly the same set of diseases that we know very well for cigarettes. Why should they be different? It's not quite as bad as sticking it in your mouth. If you've got 1,000 cigarettes an hour burning in your kitchen, well, you're going to have a lot of that. Lower risk levels, but the same set of diseases. In fact, we've done a study now in our Guatemala site on neurodevelopment, that is cognitive effects in children. Here it shows the mother's exposure during pregnancy, and the child, 6-7 years later, the child's performance on various cognitive tests, significant relationship. Now, one study not ever going to prove anything, but it's certainly what we see in other things. We see with lead exposures, pesticide exposures, traffic air pollution exposures, this impact on cognitive performance. We can't call it IQ because there are no validated IQ tests for this particular population, which is indigenous Mayan population. But do this in a population where there are validated IQ tests, and I'm sure you'd find it for IQ as well. So another thing that's come along recently is we now can link it quantitatively to the other sources of particle pollution. This is a complicated graph, I'm sorry, but I think it's worth trying to go through. This is the exposure, which is measured in inhaled dose of small particles per day. And this is the risk of heart disease, different kinds, it doesn't really matter. So somebody at 1.5, that means they have 50% more heart disease than a population not exposed, or somebody at 2 would have twice the heart disease rate as somebody not exposed. Here, these are all studies of smoking, active smoking, heavy smokers, light smokers. These are studies of passive smokers, the starred ones, and these are studies of outdoor air pollution. Now, it's a log scale for those who understand that, so a lot of variation can be hidden, but notice that it's not, they just drew a straight line through this. Not so unconvincing, is it? I'm not going to show them, but this has been done much more sophisticated modeling and attempts, now been done for pneumonia, lung cancer, chronic obstructive pulmonary disease, stroke, and heart disease. Same relationships found. Now, a colleague and I wrote a commentary called Mind the Gap, because look at this. What's that gap? Who's in that gap? That's where our village houses are. So we expect, as more and more studies are done, that we're going to find heart disease risks around this level. And a 50% increase in heart disease for 40% of the world's population, well, that's not a small matter. So, summary. Worst thing to do is stick burning stuff in your mouth. Next worst is burning it in your house. Not so great having somebody else sticking it in their mouth near you. Even bad to have it burning around your planet. These are just health. Climate, we've got more. And now the bad news. You thought that was bad news? Just because we know it's a risk doesn't mean we know how to fix it. Think of smoking. I think most people would say, the Surgeon General's report, 1964, put all the nails you'll ever need in the smoking coffin. We've added a lot more nails, but that coffin, of course, is never opening again. That smoking vampire is never coming out again. Have we fixed it? No, you couldn't even get the countries to sign the Framework Convention on Tobacco Control in 2005, and the impacts are growing. Now, California has done pretty well at lowering smoking rates, but not too many places have. Not that we have learned nothing, but we certainly have not solved it. Now, you could say, well, there are tobacco companies and various things that interfere with this. Well, the relationship between mosquitoes and disease was firmly established, you might think fairly late, during the building of the Panama Canal. But today, there are 1.4 million people dying of malaria still. We haven't fixed it. Causality, just showing causality is not enough to fix it. You have to have some way to do it. And the worst example, the most sobering or depressing example for us, is water and sanitation. I talked to a historian on this, and they say about 1890 nobody doubted the causality of human waste in the water as being a bad thing by 1890 or so. So 120 years later, we still have one-third of the world without clean water and sanitation. So just knowing it's a risk does not mean we know how to fix it, unfortunately. Why is it so hard? I'm going to be talking about, really relates to many of these, but certainly our field. We know what works, after all, what you guys have, gas and electricity. 60% of the world is using those. Clean, other problems to worry about when you have those. But it's not affordable, at least if you ask the poor to pay for it, they can't afford those. Now, affordable can be looked at on a societal basis. We don't ask the poor to pay for their vaccines either. They wouldn't, if you were just relying on the poor, you would never have any vaccines. There would be no vaccine company would ever develop them. But you have other people step in, pay. So affordable, that's quotations mark. And the other technologies are difficult. It's not so effective. And then again, there's no commercial drive. You don't have any drug company out there trying to develop it because they can't make any money off these populations. And these other technologies would be clean burning biomass stoves, using the fuel that people have, the biomass, but burning it cleanly instead of with incomplete combustion. And there's a lot of behavioral change, and that's true with dirty water and sanitation. It's true with smoking. It's true with bed nets for malaria. It's not just a matter of a vaccine. You just injected, one person has to make one decision, take their child in. Rest of their life, the child is protected in the best vaccines. Here she has to take the decision 3 times a day to use that advanced stove and use it right. That's a very different set of behavioral issues, incentives and so on. Makes it difficult. But yet, I'd say, the fact that we have protected 60% of the world means, that's reason to think we can protect, and now we know the benefits of doing so, but it will take a new type of research and development to test interventions, ways that convince the health and donor communities. Those guys who've only got $1, they want to be shown exactly what you're going to get. And we really haven't done much of that yet. But turning back to it, I'd say in order to do that, you're talking about a completely different level of funding. I mean, John Samet, who's a USC dean or chairman here, he has a slide that he starts every lecture with, which is more research needed. So I'm sure John will not disagree. But the level of funding to do these studies, the median, I called the World Bank, who has a database, the median vaccine trial costs $50 million, and sometimes they fail. We haven't had any kind of, that's an order of magnitude above any kind of research that we've ever had in this field. So we're still chasing the risk, and the money hasn't come on board yet, but we hope that'll change. This is attributed to Albert Einstein. I couldn't actually, at least Wikipedia won't verify it for me, but it's a smart thing. He could have said it, right? So I'm hoping that 120 years from now, we aren't like water and sanitation. 1890, they established causality. 120 years later, they're still struggling to find the ways to do this effectively in poor households. So I'm hoping in 2030, we aren't like them, still killing millions of people a year because we haven't figured out how to solve this problem in these kinds of households. So, final slide. Well, in Walden Pond, Thoreau said, wood is the fuel that heats you twice. Once when you chop it, and once when you burn it. Somebody I talked to said, wait a minute, you've never tried stacking wood either. But anyway, this is... but he was wrong. Heats you 4 times. The fever from the respiratory infection and the global warming. But you can fix the last 2 with moving people to clean fuels or better combustion using traditional fuels. So thank you very much.